Hey students, this is lesson 8.5, vectors. We're going to learn how to describe vectors and to solve problems involving vector addition. Go ahead and do the review, pay close attention to the definition of vector, and I'll check back with you. All right, the first thing we're going to learn how to do is describe a vector. Remember that a vector is any quantity with both magnitude, length, and direction. And a vector can be described using an ordered pair. To find the ordered pair, all you have to do is treat the vector, the terminal point of the vector as a point on a coordinate grid, and then find coordinates using the degrees and the magnitude of the vector. The magnitude is 15. So think of this as y and this is x. And if we do that, we can use trigonometry to find this vector. The ordered pair will look like this when it's a vector. And notice the little bit different arrow there when describing a vector. So what we're going to do is find y and find x using trigonometry. So y, the sine of 49 degrees, is equal to y over 15. And the cosine of 49 degrees is equal to x over 15, which is the sine adjacent over the hypotenuse and the sine opposite over hypotenuse. And so simplifying each of these, we get y is equal to 15 times the sine of 49 degrees. X is equal to 15 times the cosine of 49 degrees. So as an ordered pair, using the vector type of parentheses, x is 15 times the cosine of 49 degrees, and y is 15 times the sine of 49 degrees. We're just going to simplify those using our calculator and making sure we're in the degree mode. And we get 15 times the cosine of 49 is about 9.8, and 15 times the sine of 49 is about 11.3. Now y is in, this point here is in the fourth quadrant, so the y value is negative. So I'm going to put negative 11.3 there. And now to check this, we know that the length of the hypotenuse, which is 15 squared has to equal x squared plus y squared. So we can just do 9.8 squared plus 11.3 squared. We can ignore the negative sign since when we square it, it's going to be positive. And when I do that, I get 25 for that. And I get 23.7, but I have to remember that I rounded it, so it's pretty close. So checking and checks out. All right, go ahead, you try that. All right, problem 2. We're going to find the direction of each vector using compass directions. And this isn't too hard. We just need kind of a standard procedure here. And when we describe this, let's use north or south first. So since this vector is headed east and north, we're going to describe it this way. The vector is, using the degree angle, 31 degrees. And we're either going to say north or south first. So since it's above the east mark, east-west line, we're going to say north of, and since it's going to the right, we're going to say 31 degrees north of east. And the second one is 36 degrees. And since the arrow is below the east-west line and it's to the left of the north-south line, we're going to say 36 degrees south of west. All right, you try that. All right, now we're going to learn how to find the magnitude and direction. Now remember, magnitude is really the length but it can also be like miles per hour, something like that. So anyway, so we have a cruise ship and docks 120 miles east and 45 miles south where it began. Let's just draw a quick picture of what that might look like. So 120 miles east, so this is like 120, and then 45 south, so this would be negative 45. So the ordered pair that describes that is 120, negative 45, and so this is the direction the ship took right there. Okay, and we want to describe that using how many miles the ship is from where it started, and you should notice a little right triangle there. So we need to know two things. We need to know this distance here, travel, and we also need to know, I'll just call it x for now, the number of degrees it is from where it started. So using the two numbers we have in Pythagorean theorem, we're going to say that d squared, you can also use the distance formula, but d squared is equal to 120 squared plus 45 squared. I can ignore the negative sign there. And when we do that, we get, then we get d is equal to the square root of 120 squared plus 45 squared. And when we do that on our calculator, we get about 128 miles. And the second thing we have to do is figure out the direction. To find that, we're going to use trigonometry. That'll give us a degrees. And we know that the tangent of x is equal to the side opposite. Remember, in the opposite here, it's 45 down. And the side adjacent is the 120 distance there, so 45 over 120. To figure this out, we're going to have to use the inverse tangent. So x is equal to the inverse tangent of the ratio 45 over 120, which is about 20.556. So putting those two together, and we know we're going south and to the left, so it's a south and east direction, so we're going to choose D. 128.2 miles, 20.6 degrees south of east. Go ahead, you try that. All right, to add vectors, it's pretty simple here. All you have to do is add the coordinates inside there. So if you want to add vector A plus vector C, you just add the coordinates x of 1 plus x of 2, y sub 1 plus y sub 2, and that's called the resultant vector. So in this problem, we're just going to add vector A plus vector B, and that's going to equal 5, 2 plus negative 3, 3, and that, so all we have to do is add 5 plus negative 3 to get the x coordinate of the resultant vector, and 2 plus 3, and we get 2, 5 for our answer. Go ahead, you try that. All right, applying vectors. The last thing we're going to do is learn how to apply vectors and to figure out speeds or directions or something like that. In this case, we're looking for the speed of the airplane and the direction. So it says an airplane flies due east at a speed of 275. So if we were to draw a coordinate diagram of this, the airplane's heading this way at a speed of 275, and we can represent this as how far it goes in 1 hour if we want. So it's 275 miles per hour. And the wind is blowing due south at a speed of 15 miles per hour. So the airplane's actually going to end up here because of the speed of the wind. So this can be represented by the coordinate pair 275, 15, which is 1 hour's worth of travel, negative 15 actually. So the first thing we're going to do is find the resultant speed, and that's going to be the distance, so how far it went in that first hour. So D is equal to, using Pythagorean theorem, square root of 275 squared plus 15 squared, which, calculating that out, we get about 274 miles in that hour of travel. And then our direction we're going to find by using, we want to find this value right there, we'll call that x. And we know that the tangent of x is going to equal the side opposite, which is 15, divided by the side adjacent, which is 275. And to find x, we're going to use the inverse tangent of that ratio, which is about 3.1 or so. And then we're just going to give that a name. So about 3.1 degrees south of east is our direction. And our speed is about 200, actually I got off a little bit on that, about 275 miles per hour. All right, you try that. All right, that's it for this lesson. Go ahead and do the lesson check, and we'll talk about this next time we meet in class.